Hello everyone, this is Girish with ANSYS Structural Tutorials. So here I'm with a new session on stress singularity. Agenda here is to deal with the multiple L brackets. I'm gonna just take these two brackets into single workbench and I'll run the analysis with static structural, and we'll cross check the stress singularity, and we'll let you know how to deal with the stress singularity and what and all things we need to do. So what is the importance of fillets as well as the mesh convergence, why I need to take care of mesh convergence, that also we'll see, and we'll also deal with the parametric study. Okay, well, we'll directly start with the modeling first. We'll use the SolidWorks to model it instead of simply importing from the step files. Okay, you can even use the ANSYS workbench to model it, but it will take more time to deal with the modeling in ANSYS workbench. I think so. I don't know much about that. I feel SolidWorks is easy for modeling. Okay, let's start with that. Okay, we'll create the model here, the L bracket. Again, define the dimensions. Again, take any dimensions, not exactly as per the manufacturing, because we are simply running the test run to understand how the software works. Okay, so 150, I'll make it 75. Well, so I feel the SolidWorks software is great to deal with the modelings, so I'm using it. So instead of drawing each and everything, a simple line can help us to create a model with mid-plane. I'll define the dimensions. 10 and thickness is 10 is quite less. I'll make it 15. Only one side, so even the length will be 15. So kind of L bracket with a square path line. Okay, fine. So this is one. Now I need one more. So for that, I'll simply refer the extra plane so that I can create one more bracket without fillet and with fillet brackets. What I'm gonna do now is I'll take these two models in one single platform to run the analysis instead of running the two separate analysis for these brackets with fillet and without fillet. So I can simply use single platform and I can get the results, right? Then I'll try once. Okay, I'll hide this plane, and here I need the fillet. I'll add it. The radius is 10 mm. If you want, you can increase. For now it's okay. The model is ready. I can save this one first, save as a step file as well as save as the part file. Whenever you want, you can come and modify as well, right? Okay, this is the part model, and then again I'll save it as a step file. Once the modeling is done, you can directly import this model to ANSYS. Yeah, so before that I'll save this as a step file, maybe 2014 file. You can use it as a format. You can even use IHS formats and parasolids and all. It's just your considerations. Okay, these are the different analysis types here, so you already know that. So static structural analysis I'm gonna do to verify the stress singularity here. So how the stress singularity will happen in model, so to avoid it, what to do, and then what is the importance of fillet in the stress regions, stress singularity regions. Okay, we'll see these things. The first thing is I'll browse the model instead of creating, as I already told before. So this is a step file. I'll import it. So you can see the green tick on the engineering data as well as geometry. The engineering data structure by default still I'm selecting. Now the model, so here you can edit the modeling phase. So there you can even measure it, and you can assign the boundary conditions. The setup and the model consist of single workbench here. This is the modeler. You could see the models. both the models at a time, with fillet and without fillet. You can see the material for both, it is structural steel. Okay, and now the connections, there is no connections, it's a simple part model. So if you have the assemblies, you can assign the connections. The mesh, there are different types to assign, so I'll select the method. So in the method you can select the models separately. Okay, this one and even this one. Select the method again. This is the automatic method too, this body, and select it into body. Okay, you can even rename it. This is without fillet, and that L bracket is with fillet. Okay, so this is done. Next thing is to refine the mesh. You have the mesh controllers here and the mesh edit if you want to make the changes. So in the refinement, you can define the refinement level. So here, this is the face which I have selected, the fillet region, not this one. The refinement levels, you can define it up to 3. Okay, so this is level 1, level 2 and level 3. Depending upon the mesh size you're gonna keep, according to that the refinement will be multiplied by 2 or 3 or 1, like that. Okay, yeah, so this is the mesh you could see. For now it's okay, you can even still refine it. I can go to the default method, and here you could see the sizing. So there are different methods to deal with this, the relevance, as well as we have the element size and the span angle. Center, you can define it as fine as well. So this is the size function. You can define different options like proximity separately, proximity and curvature and all. Okay, so I'll select the proximity and curvature for this analysis. Let's see how the mesh will help us to just extract the results here. The grout rate 1.2 is the best one. I can define the same. The size 5 mm. Okay, 2.5 is too less. Remember, the tetrahedral size should be greater than whatever the maximum face size is there. So that is the criteria. If it is not, your mesh will fail. Or else you can even reduce that sizes as well. Okay, so this is how the mesh will looks like. So this is comparatively finer, right? Okay, now I need to assign the supports. So you can go to the static structural. From there you can select the fixed support. This face should be fixed for this. One more fixed support for L bracket with fillet. That's done. I need to assign the loadings as well. Okay, here I'm gonna assign the force towards downwards. So instead of direction, you can select the instead of vector, you can select the component to define the direction, because it is only with respect to the x direction. So I'll use the components, XYZ components. So here it is 10,000. If I do that, it might be positive, so I need it towards downwards. So I'll change the sign here, minus. Okay, yep, so this is fun. One more I need for L bracket with fillet. So you can assign the same force, because I need to validate for the both the components with the same boundary conditions. it's minus 10,000. Okay, we are done with the boundary conditions here. We have assigned both. Next thing is to result extraction from the solution. What and all you can extract. So let's say I need the stress, that is von Mises stress, not for all the bodies. Here you can refine your results only for this body, not the face. You can filter it out for the body and select entire body. So this is for L bracket with fillet, and one more equivalent von Mises stress. And here instead of all bodies you can select the L bracket without fillet. Just select the body here. Okay, so this is how you can just differentiate your results while dealing with the multiple analysis in a single platform. So one of the great advantage. Okay, well, you can rename this as well, so to avoid the confusions while just dealing with the results. Yeah, so the renaming is done. We have defined the boundary conditions and everything. You just need to run this analysis now to get the results. We have the solve tab at the top, the menu tab, and right now here I'm just taking out these parameters, that is the results, what and all I'm looking for. The maximum von Mises stress I need into account, and even from the mesh I need the maximum touch size to create the parametric study. I'm just extracting these parameters to compare the results later on. Okay, well, so once you run the study, you could see you have the results. That is 1581, and without fillet model it has 1626 megapascal. Okay, I think whatever the results we are getting, it is too high, and the whatever the loading we have applied, it is very much, so we can reduce it later. Okay, now the thing is I need to create the parametric study, so you can simply double click on this parametric set, and you can here define the values. This is the parameters which you have extracted, and this is the table of points. Here you can modify your values. So let's say, so this is the dp0 is the study. Okay, so if you save the model, so these all the studies will be saved, like dp0, dp1, dp2. How many studies you're gonna create? No, that much studies will be created separately if you use the proper saving option accordingly. So 654321 and 0.5, it's okay. Like this you can create the multiple studies with respect to meshing. So once you do that, you can run this entire study at once by using this update all design points. So it's gonna take some time to just extract the results. The current right now is dp0, the 6 mm mesh size. Okay, you could see the results. I think there is something wrong. Let me just modify this, the mesh. So here the requirement level I'll keep it 1. Okay, so actually the mesh is too fine, so for that it is creating issue. So maximum text size I'll keep it 10, and the face size should be lesser than that or equal, so I'll keep it as 8 mm. Okay, and now with respect to these, I'll add this as well, so maximum text size and face as well. Okay, according to that you could see the results. Now here I'll modify the values according to the requirement. The maximum text size is 10, face size is 8, like that, 8, 6, 6, 5, 5, 4 and 4, 3. So we have seen less than 3 mm size. If I do it, the results are not extracting. So now I'll update these parameters. Accordingly I'll get the results. So you could see this is the results tab. Without fillet study, you could see the results are converging accordingly. Okay, from 675 to 883. But here with fillet, you could see it is 733, that is 781. So let's see now how exactly it's gonna help us to deal with the convergence. Okay. With fillet is converging, without fillet is diverging there. Okay, from here parametric chart, you can double click on it to extract the chart. So we have the parametric chart here. So along the X bottom you can select the text size. Okay, and along the Y left you could choose the with fillet or without fillet study to extract the result. We do the same. So this is with fillet. Okay, you could see from text size 10 mm to 4 mm it is converging. The graph is straight according to the mesh when you reduce it. Okay, you could see for 6, 5 and 4 the curve is slightly straight. So from this we can conclude that the result is converging for the model with fillet. Now I'll create one more chart accordingly. So this is for with fillet. Now I'll simply double click on it. You will have the one more chart, and here you can add the one more study which we have created. So along bottom the total size, along Y direction I'm having this. So here you could see as I change the mesh, the results are diverging. So this should not happen. This is known as stress singularity, that is the force per unit area is infinite. So from these graphs we can conclude, so fillet plays very important role at the shaft corners. So if it is not, the force will diverge infinitely, as you could see in this particular graphs. So now you can even use the current study, that is dp4, into account. So you can even select this copy input to current, so that you can just show this particular results to the workbench, all the results and all. Okay, so I have done the same here. So you can update this, or else you can save this entire study with respect to all the parametric studies you have created, dp0 to dp4 or dp5. Then you can just separately open that projects. That is one way to deal with this. Okay, so once you are done with this updating stuff, you can just simply review the results here. So from this particular study we have seen that the model with fillet has the convergence criteria. As you reduce the mesh, the results will also converge. Okay, we have seen how to utilize the charts and the parametric study and the models, the multiple models in a single workbench to run the analysis. Okay, let me just jump to the results tab here to just review the results. Before that, you could see the parameters here. You could see the dp4 results has been copied to current. so that you can just preview the same results. Okay, now this current. Let me just preview these results by using the solution tab. You can go to the projects and you can use the results preview by using the modeler only, so even you can preview the results there as well. So it is connected. You can even directly access the results for CFD analysis and previewing the results for Fluent and CFX as well. Okay, that is very good option. Okay, you could see in the solution stage we have the results for von Mises stress. So with fillet and without fillet, you could see this is for with fillet 781. So I have reduced the value here. Okay, the force is 5000 Newton. It is 883. That is without fillet. So the factor of safety is anyway more, because we have considered the first value more, or taken only 500 Newton. It's okay, but this is how you can just verify your results by using the stress singularity and mesh convergence and running the single study on multiple studies on single platform. Okay, that's all about this. Quickly to summarize everything, we have gone through L bracket analysis, where we have considered the L bracket with fillet and without fillet models, and we have run the simple static analysis to cross check with mesh convergency and the stress singularities, and the importance of fillets at the fillet regions where exactly the sharp corners are there we need to deal with the fillets. Okay, we have utilized the parameters to deal with the results, so just changing the parameters which we are looking for and getting the required results will help us to get the mesh convergence with respect to the accurate results. Okay, that's all about this study and session. Thank you all for supporting. Please do like and subscribe. Thank you.